Hello everyone. In this video, we are going to discuss about the finite automata to regular expression. So that means converting. So previously we have seen if they give regular expression, how to draw a finite automata for that. So now this is the reverse thing. So if they give the finite automata, the diagram, whether it is a DFA or NFA, for that you need to write a regular expression. So for this we are using a process. So using that process, you can write the expression, right? So coming to the process, so the process is, so already we have discussed about ordinance theorem in the previous lectures, right? So using that theorem, we are going to write the regular expressions here. Okay. Now in this process, the first point is, let Q1 be the initial state. We know. So in the given diagram, consider Q1 will be the initial state, and along with Q1, we may have some other states also. So consider those states as Q2, Q3, Q4, and so on, Qn. So whereas out of all these states, whether it may be Q1, Q2, Q3, or so and so on, Qn, so one or more states will be the final states, right? So where Qj will be the final state, j is less than or equal to n. So out of all these states, one or more states will become the final state. So now consider, let alpha ji represent. So alpha ji represents the transition from Qj to Qi. So transition in the sense, it's just like the input symbol. So alpha is nothing but the one of the input symbol. So if I provide some input to Qj, then it will go to Qi, right? So Qj on some input alpha ij or alpha ji, it will go to Qi state, right? So that is the meaning of this statement. Now, if it is like this, for example, we'll write that. So we'll write that statement in the form of diagram. So Qj to Qi. What is the input you are providing? Alpha Ji, right? So alpha Ji is the input which you are providing to Qj, then it is going to Qi state, right? So now in such case, you can write Qi expression, Qi expression. So Qi is nothing but whatever the incoming paths are there. So what is the incoming path we have? Alpha Ji is coming from where it is coming? It is coming from Qj. So this will be the expression for Qi, right? So all the incoming things, all incoming paths, for all those incoming paths, we need to write the expression like this. So if Qi is an initial state, so here Qi is not an initial state. If it is an initial state, along with these things, you need to add one more symbol, extra symbol, that is epsilon. So if it is initial state, then only you need to add this epsilon, right? So for all the states, you need to write the expressions like this. Then similarly compute the final state, which ultimately gives the regular expression R. So here in the diagram, we may have multiple states, right? For example, consider I have a diagram called like this, Q3, Q4, whereas Q1 is the initial state, Q4 is the final state. So we have some diagram like this. So we will find the expression for all these states, right? Q1, Q2, Q3, Q4. But what will be the final expression, final solution for this diagram in the sense, the final state. So what is the final state for this problem? Q4. So the Q4 expression will become the final expression for this diagram. Okay, so that we are going to do here. So now we'll see some problems using this process. So the first thing is construct regular expression for the given DFA. So this is the given DFA. So sometimes it may be NFA also. Okay, so actually in this diagram it is NFA. That may be any finite automata, whether it may be DFA or NFA. See, Q1 on 0 it is going to Q1 itself. So on 1 it is going to Q2. So Q2 on 1, Q2 on 0, Q3 on 0 and 1. See here if you observe Q3 on 0, like that's right. So this is DFA only actually. Okay. Now let us build the regular expression for each state. Okay. Now first coming to Q1. Actually Q1 is the initial state here. Of course final states too. But if it is the initial state, what we need to add extra? We need to add epsilon, right? So epsilon we need to add. Along with that, all the incoming paths. So Q1 is having only one incoming path, that is on 0, right? Q1 on 0. From where it is coming? Q1 only. And where it is going? Q1 itself. So the expression for Q1 is from 0, like from Q1, by taking 0 input, it is coming. But as it is the initial state, you need to add epsilon also. So this is the expression for Q1. And now coming to Q2, so what are the incoming paths we have? On 1, from Q1 it is coming. So Q1 on 1 plus Q2 on 1. So this is the expression for Q2. See here, Q1 on 1, Q2 on 1. In the same way, Q3 we have three parts. So Q2 on 0, Q3 on 0, Q3 on 1. So Q2 on 0, Q3 on 0 as well as 1. So I'm writing 0 plus 1. So I'm taking Q3 as common here. So whatever you want, you can write it this. So we got three expressions now. So out of these three expressions, what is the result? So if I observe this diagram, in this diagram we have two final states, that is Q1 as well as Q2. So if I add these two states, I'll get the final expression, final regular expression. That will be the answer for your diagram. So now what I need to do, I need to find out the regular expression for Q1 as well as Q2. So this is the value for Q1, but see in the right side, if you observe, you got the value Q1, but we don't know the value of Q1, right? So first you need to find out the value of this Q1, then Q2 also. So in the right side of Q2, if you observe, you are using Q1 as well as Q2. So right side, you should not get all these states. It should be like an expression in terms of zeros, ones and epsilons, right? So now we'll try to solve this. So first we will consider Q1. So what is the expression for Q1? Epsilon plus Q1 into 0. So this is the given expression. Now we use Arden's theorem. So what is the Arden's theorem? We have, if the expression is in the form of R is equal to Q plus RP, for this we have a unique solution called QP star. So wherever you get the expression in the form of Q plus RP, then instead of this, you can replace it with QP star. So now we'll consider our expression in this form. See, Q1, this I'm taking it as R, epsilon is Q. What is Q1? Q1 already have considered it as R into 0. So 0 I'm taking it as a T. So Q plus RP. So this expression is in the form of Q plus RP. Then what will be the solution for this? QP star. So QP star. What is Q here? Epsilon. P star. P is 0. So 0 star. So epsilon into 0 star. Again it will become 0 star only. So what is the solution for Q1? 0 star. So now we got the solution for Q1 in terms of only inputs. That means only zeros and ones. Now we need to find out another final state. What is another final state? We have Q2, right? So Q2 is another final state. But in this Q2, you're going to use the Q1 value. But we got Q1 value from first equation, right? So what is Q1 value? Q1 value is 0 star. Just substitute this value here, right? So 0 star 1 plus Q2 into 1. Now again, I'm taking this expression in the form of Q plus R. So this is Q, R, P. So R is equal to Q plus RP. What is the solution for the QP star? So what is Q? This is the Q and P star is 1 star. So now we got value in terms of zeros and ones without any states. Now we got the value for Q1, Q2. So what is the final answer for this problem? Q1 plus Q2. So add these two things. Add these two things. This is Q1. This is Q2. So if I add these two things, I'll get the final regular expression for this problem. So 0 star as it is, but 1 into 1 star again it will become 1 plus. We know that, right? 1 into 1 star will become 1 plus. So I can write the expression like this. So this is the final expression for this problem. So we will take one more problem here. It is NFA. So I already told you whatever it may be, the diagram may be NFA or DFA, the process is same, right? So now first Q0, but for Q0 we don't have any incoming paths here. But as it is the initial state, we need to take Q0 as epsilon, right? And coming to Q1, what are the incoming paths we have? On 0, Q0, on 1, Q0, on 0, Q1. So 0 Q0, 1 Q0, 0 Q1. And coming to Q2, 0 Q1, 1 Q1, 1 Q2. Right? So these are the things I'm adding. So now what is the final state for our problem? Our problem, the final state is Q1. So I need to solve only the expression Q1. See here, this is the Q1. But in Q1, we are using Q0 and Q1. But we know Q0 value is epsilon, right? So Q0 value is epsilon, you can substitute that value directly. So if I substitute that value here, so what is the thing I'm getting? So I'm taking 0 plus 1, this is plus 1. So 0 plus 1, 0 plus 1 plus Q1 into 0. Q1 into 0. So now consider this expression as R is equal to Q plus RP format. So if the expression is in the form of Q plus RP, what is the solution for that? R is equal to QP star. So what is Q? 0 plus 1 is Q. P is 0, 0 star. So this is the final answer for your diagram, given diagram, right? So just you need to focus on the final state expression. But if in that final state expression, if you are using any other states, right side, Q0, Q1, whatever it may be, first find out the solution of those states, then substitute those values in the final state expression. Then you'll get the final expression. So we have some homework problems here. So just try to solve all these problems. You can take a screenshot of this and you can try all these problems. So totally we have 5 problems. Try to solve this. So here if you observe in the third diagram, they have not given any diagram, but they have given P as initial state, Q as a final state. So they're given transition table. Using this transition table, you can draw the diagram. So this end of this session. I hope everyone is clear with us. Thank you.